Okay, so how do I convert 84 degrees, 84.64 degrees into degrees, minutes, and seconds?
Take the 0.64 on the end, and times that, multiply that by 60 minutes over 1 degree.
Excellent.
Which, if I'm not mistaken, would give you 3.
Great. And now what do we do? Good. Even? Awesome. So now we can write 84.64 degrees equals 84 degrees, 3 minutes, 24 seconds. Does that make sense, everybody? Awesome. More definitions. A central angle is an angle with a vertex at the center of the circle. And what we're going to do is use the standard position of an angle and central angle together. We're going to have the positive x-axis will be the initial side. The terminal side will be the other side of the angle. The vertex is going to be the origin. And we've got a circle. The circle has radius r. And this angle is now called a central angle because it's inside of a circle. 1 radian is a central angle where the degrees, where the radian measure actually, of this angle is exactly the same as the arc length. So the arc length is this distance along the circle. And the formula for arc length, theta is equal to S is the arc length, R is the radius. And we're saying that 1 radian, that's the value of theta, is equal to, it'll be whenever S and R are the same. So the radius is the same as the arc length, and that gives us exactly 1 radian. So there are like, I don't know, 6 radians in a circle, but not exactly, because pi comes in. 1 radian is denoted 1 radian or 1 rad or 1, because radian measure has no units. When 2 lines intersect a circle, the part of the circle between the intersection points is the intercepted arc. And again, if you're using radian measure for the angle, then theta is equal to S, the arc length, divided by R, the radius. So let's convert negative 15 degrees to radians. And we're going to use this relationship. 180 degrees is pi radians. So I'm going to start with negative 15 degrees times. My unity is going to be 180 degrees is the same as pi radians. I've got degrees that I'm starting with, so degrees is going to be in the denominator. Pi will be in the numerator. Now degrees are going to divide out. So I've got negative 15 pi in the numerator and 180 in the denominator. We don't have degrees anymore. Now we want to reduce this fraction. So what is common between 15 and 180? Does 15 go into both? 15 goes into 180, 12? So we get exactly pi 12ths. Negative. So negative 15 degrees is exactly the same as negative pi over 12. So let's just do this as a class, but I want you all to tell me what to do. We're going to convert 300 degrees into radians, and we're going to use this relationship that 180 degrees is pi radians. So how do we do it?
Multiply by pi over 180.
Okay. Excellent. Can we reduce? Let's go ahead and write it as a one fraction. Is there anything common between 300 and 180? Okay. 6 goes into 35 times. Oh, so yeah, it's 5 over 3, is that right? 5 pi over 3. So 300 degrees is exactly the same as 5 pi over 3 radians. Very good. Well, now let's start with radians and go to degrees. We have the same unity. So we're starting with 5 pi over 6. And this time, we're starting with radians. So radians will be in the denominator. Degrees will be in the numerator. And I want to simplify this fraction before I multiply. 6 goes into 18 evenly. Excellent. So we got 5 times 30. And what happens to the pi? Excellent. So 5 pi over 6 is exactly the same as 150 degrees. Well, let's start with 3 pi over 2. And how do I use this relationship to convert 3 pi over 2 radians into degrees? Excellent. And now what? Can we cancel anything else out? Can we reduce it?
Yes.
Okay, great. And now it's a lot easier to multiply. 3 times 90 is 270 degrees. So 3 pi over 2 is exactly 270 degrees. This definition is really, really important. We're going to use it all semester long. Coterminal. 2 angles in standard position. Standard position was where the origin was the vertex and the initial side is along the positive x-axis. 2 angles in standard position with the same initial side and the same terminal side are coterminal. It doesn't mean the angles are the same. It means the beginning and ending places are the same. So do you see that 30 degrees is coterminal with 390 degrees. It's also coterminal with 750 degrees. Or if you go backward, it's coterminal with negative 330 degrees. And the way that you go from one to the other is by adding or subtracting 360 degrees, which is one circle. Do you see the definition? Now, this notation, this is interval notation. And this says, if it's a squared off bracket, that means we include it. If there's a rounded bracket, that means we don't include. So we want to find an angle between 0 degrees and 360 degrees, and it can be all the way to 0, that is coterminal with negative 251. Since we're starting negative, that means we add 360. So negative 251 plus 360 and 0 minus, let's see, we've got to borrow. 10 minus 1 is 9. 5 minus 5 is 0. 3 minus 2 is 1. So 109 degrees is coterminal with negative 251 degrees. What about a negative angle that is between negative 2, negative 720 degrees and, well, that's bigger than negative 720 and coterminal with negative 251? Well, now we're going to subtract 360. So we start with negative 251 and subtract 360. And we get negative 611 degrees. So we're adding and subtracting 360. What if we wanted an angle larger than 109 that was coterminal with 109 degrees? How would we do that? Good. So 9, 6, 4 degrees. So all of these angles are coterminal because they have the same initial side and the same terminal side. So tell me what this interval means. I've got square bracket 0, comma 2 pi with a parentheses. Excellent. And I should have written this one as negative 4 pi up to negative 2 pi. Okay. Pardon? So because negative 207 and negative 720 degrees is twice around in the negative direction. 360 is once around, and 2 pi is equivalent to 360 degrees. So let's start with an angle in radian measure and find some coterminal angles. So we've got negative 4 pi over 5. And how do we go toward, how do we make it positive? It's starting negative. Or 2, yes. So we're going to add 2 pi. And I had to have a common denominator. The common denominator is going to be 5. So I'm going to multiply by 5 over 5. And we get negative 4 pi over 5 plus 10 pi over 5. And what is that? Good. So negative 4 pi over 5 and positive 6 pi over 5 are coterminal. How can I get an angle that is coterminal with these two angles that is between negative 4 pi and negative 2 pi? In other words, how do we go backward? We add 2 pi to go forward. What do we do to go backward? Yeah, we're going to subtract 2 pi. So negative 4 pi over 5 minus 2 pi over 1. And I write 2 pi over 1 because I'm combining with a fraction. We have to get a common denominator again. And we get negative 4 pi over 5 minus 10 pi over 5. And what is that? Yeah. So adding and subtracting 2 pi or adding and subtracting 360 degrees moves an angle, or it helps you find an angle coterminal with any other angle. Arc length is the S. Arc length is equal to the radius of a circle times the angle, as long as that angle is measured in radians. So you can go back and forth between the angle and the arc length as long as the angle is in radians. And the way that we get the conversion factor for circles is exactly here. So we've got theta is equal to S divided by R. Well, if we let S be this whole circle, what is the circumference of a circle? Good. And how can we reduce that fraction? Yeah. So the central angle that intercepts the entire circle has measured 2 pi. And that's how we get that 2 pi equals 360 degrees, and then we can divide by 2 to simplify, and we get pi is equal to 180 degrees. And remember I said there were about 6 radians in one circle. It's not even because it's all in terms of pi, but it's about 6.28. The area of a sector is found, as long as the angle is measured in radians, it's found by taking 1/2 times the radius squared times the angle. Also, this is very important. There are loads of definitions and formulas in this class. You don't have to memorize them. Just keep a running list that you can refer to. You can use it on the test and on the quizzes, because that's a lot of trigonometry, or getting ready for calculus, is knowing where to have the right formula that you need. So we're practicing. Okay, so don't memorize all these things, but we do need to remember them. Find the exact length of an arc intercepted by a central angle. Theta is equal to 3 pi over 4 on a circle of radius 2.8 centimeters. So theta goes from the positive x-axis, and we don't have to worry about how I know that it's in the second quadrant yet, but it is in the second quadrant. And we know that the radius of this circle is 2.8 centimeters. So remind me what the formula is. Remind me by looking at it yourself and tell me how I can find this arc length.
Theta R?
Yeah. So theta is 3 pi over 4. R is 2.8. When you're working with two fractions like this, the easiest way is to rewrite this as where the main fraction line is a division sign. So we're going to rewrite this as 3 pi over 4 divided by 2.8. And we want an actual value, accurate to
Why
one
is it-
decimal. Go ahead.
Why is it not on like theta times R?
Did I misremember? You're absolutely right. Thank you so much. Who said that? Thank you so much. So we've got S is equal to our theta 3 pi over 4 times 2.8.
Honestly thought you were changing it out. It's like how it's supposed to be.
No. Some things I remember really well and some things are not as important and I don't remember them really well. If you have a calculator on your phone and you turn it sideways, you'll get a scientific calculator. And for our class, this is enough. You don't have to get, unless you already have one, you don't need to get another calculator. So we've got 3 times pi divided by 4 times 2.8. We want the answer to be accurate. Here we go. To one decimal place. So what is the value of S? Good. They have to say. So if they want an approximated answer like this one, they'll say 1 decimal place or 2 decimal places. If otherwise, they'll say exact. And then we just reduce the fraction and leave pi in there. Okay, the unit circle. The unit circle is the most wonderful thing in the whole world, and you'll remember it when you have Alzheimer's. So a unit circle is just a circle with radius 1 centered at the origin. So we know some points. We know that along the positive x-axis, we have the point 1, 0. If we go up the positive the positive y-axis, we'll get 0, 1. The negative x-axis is going to be negative 1, 0. And the negative y-axis will be 0, negative 1. The formula for a circle is x minus x naught squared plus y minus y naught squared equals the radius squared. This word that I just said is not. It's pronounced not, and it is the word that represents this little circle. It's a little 0. Where x naught, y naught is the center. Well, for our case, 0, 0 is the center. So we have x minus 0 squared plus y minus 0 squared. And our radius is 1. So 1 squared, and we can simplify it. X squared plus y squared is 1. So this is the formula for every single point on this circle. That means if I know one of the coordinates, I can find the other coordinate. So let's see. Well, let's just use their example here. I've got the point -1/2 comma square root of 3 over 2. Say we were given that one of the coordinates is square root of 3 over 2, and we're trying to find the other one. So I know x squared plus y squared is 1, and that y is the square root of 3 over 2. Well, what is the square root of 3 squared?
3.
Good. And 2 squared? 4. Good. I want to find x. So that means I want everything else on the other side. I'm going to subtract 3/4 from both sides. So I need a common denominator. And that means 4. So I've got 4 minus 3 all divided by 4, which is 1/4. This is really important. We're going to do this so often all semester long that you'll think that I invented it. We're going to take the square root of both sides of this equation. Whenever you take the square root of both sides of an equation, you must put a plus or minus sign in. Every time you take the square root of both sides of an equation, you must put a plus or minus sign in. Well, the square root of x squared is x. The square root of 1 is 1. And the square root of 4 is 2. So the first coordinate has to be either positive 1/2 or negative 1/2. So here's square root of 3 over 2. And here's also square root of 3 over 2. Oh, I'm going the wrong way. This is square root of 3 over 2. And here we go. So this is the other point with the second coordinate, positive square root of 3 over 2. The possible first coordinates are positive 1/2 and negative 1/2. And we already did this, so I'm going to do something else. What if we had a first coordinate of square root of 2 over 2? That was x, and we want to find y. How do we do that?
Formula x squared plus y squared equals 1.
Excellent. And now,
And x would be square root of 2 over 2 squared plus y squared.
all right. And square root of 2 squared is good. And 2 squared is so we've got essentially 1/2. And we want to find y. 1 minus 1/2 is 1/2. Now, what do I do to find y?
You go next one. So,
And what do I have to throw in if I take the square root of both sides? Good. That'll definitely be a quiz question. Okay, so the square root of y squared is just y. The square root of 1 is 1. And the square root of 2 is just square root of 2. This answer is perfectly beautiful to me, but Connect Math doesn't like it because there's a square root in the denominator. So we have to rationalize this fraction, which means we want to multiply the denominator by something to make it a whole number rather than a square root. So we're going to multiply by square root of 2 because square root of 2 times square root of 2 is 2. But whatever we do in the denominator, we have to do also in the numerator. So we get positive or negative square root of 2 over 2. And that means if we have the first coordinate of, I'm doing it backward again. Here we go. If we have the first coordinate, square root of 2 over 2, or here's also square root of 2 over 2. The second coordinate in the first quadrant will be positive square root of 2 over 2. That's the plus version. And in the fourth quadrant, negative square root of 2 over 2. Let's go over to the quadrants real fast since I'm using that word and I didn't define it. Quadrant 1 has positive x and positive y. Quadrant 2 has negative x, but still positive y. Quadrant 3 has negative x and negative y. Quadrant 4, x is positive again, y is negative. Okay. Let's see. Let me think of a point. Actually, I've already done them, but one of the things I want to show you is there are only certain points on the unit circle that are nice. So here's our unit circle. If either value is square root of 2 over 2, the other value has to be also square root of 2 over 2. If either value is 1/2, call this 1/2, the other one has to be square root of 3 over 2. Those always go together. So here the first one is 1/2. The second one must be square root of 3 over 2. Square root of 3 over 2 and 1/2 go together. Square root of 2 and square root of 2 over 2 go together. And then it extends to the other quadrants if you change the sign. Okay. Now I just want y'all to follow this. You're not responsible for reproducing this, but it's important that you see it. So what we want to do is connect central angles with the point on the unit circle. So we've got a unit circle Oh, I see. I forgot that we were doing this. So on the unit circle, only on the unit circle, instead of S being used for arc length, we use T. So T is the arc length. Instead of S, only on the unit circle. Not that it's just the letter that is normally used. So we've got a point P that has an X and Y coordinate, and we have an angle. And the arc length is the value T. And we do have one relationship. We know that here, the arc length is T. The radius is 1. So we get that the arc length is equal to the angle, the central angle. And that's really crucial. That's what's special about the unit circle. The distance along the unit circle is exactly the same as the radian measure of the angle. What we're going to do is take the real number line and wrap it around the unit circle along the edge, where t equals 0 is going to go at the point 1, 0. So in other words, we're taking something like a number line with radians marked, and we know that pi goes all the way over here to the point -1, 0, and pi over 2 will be at the point 0, 1, and it'll continue to wrap and wrap and wrap. If we go clockwise, then we're looking at negative angles. But all that means, all a negative measure means is backward. It doesn't mean it has a negative value. It just means we're going backward. So it's a direction. So positive angles are counterclockwise, negative angles are clockwise. And we did this already. Okay, so since this is a unit circle, the radius is 1, we're going to call the arc length t, and we do get that t and theta are the same as long as theta is measured in radians. So now what we want to do is get some special values. So we've got 45 degrees, which is pi over 4. And we want to find the point along the unit circle that corresponds to pi over 4. So we're going to look at this triangle, which is a 45, 45, 90 triangle. And we're going to think of it as pi over 4, 90, or pi over 2. And the relationship of every single 45, 45, 90 triangle is that however long the sides are, the hypotenuse is going to be square root of 2 times that. So for us, we've got one, oh, no, what am I thinking? We've got 1/2 and 1/2, but let's see why. I'm going to come back to this in a second. So we've got this triangle. I'm going to draw it again. It's a right triangle. And it's pi over 4, 90. And we know the distance from the origin to this point is going to be 1. We also know that the legs have the same distance. So I'm going to call them both x, and we want to find x. So I know, because I know that this is the unit circle and x squared plus y squared is 1, I know that x squared plus x squared is 1. 2x squared is 1. And how can I find x? All right. So we get that x squared is the square root of 1/2, or that x is positive or negative 1 over the square root of 2, or positive or negative square root of 2 over 2. That means that every single midpoint on the unit circle is going to have the coordinates square root of 2 over 2, comma, square root of 2 over 2, where we're going to change the sign. In the first quadrant, they're both positive. In the second quadrant, x is negative. In the third quadrant, they're both negative. In the fourth quadrant, x is positive. So we know the point that corresponds to pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Absolutely, thank you. Well, now let's look at the part that I skipped. What about a 30, 60, 90 triangle? Again, we're going to have the hypotenuse, and we're going to use the fact that whatever the hypotenuse is, the base is 1/2 times that hypotenuse, and the height is square root of 3 over 2 times that hypotenuse. And we're drawing that triangle inside the unit circle. So we know the hypotenuse is 1. The angle here is pi over 6. And I also know, if I draw the whole triangle, I'm doubling. I also know that this other hypotenuse is still 1. Well, that means, let's see, the triangle, the original one was pi over 6, pi over 3, pi over 2. Pi over 2 is 90. Well, I doubled the pi over 6 one. Pi over 6 plus pi over 6 is pi over 3. So now this big triangle is pi over 3, pi over 3, pi over 3. That means all the sides have to be the same. That means we've got 1, 1, 1. But this vertical length is divided by the positive x-axis. And that's how we know that one of this y value is going to be 1/2. And the y value in the fourth quadrant is going to be negative 1/2. And let's just go through the steps again for fun to see what the possible first coordinates are. So if if y is 1/2, we know that x squared plus y squared is 1. X squared plus 1/2 squared is 1. X squared plus 1/4 is equal to 1. We're going to subtract 1/4 from both sides. So I've got to get a common denominator. 4 minus 1 is 3. And then we do what? Good. And do what? What do we have to put in? Good. Good. So we get either positive square root of 3 over 2 or negative square root of 3 over 2. So we've got positive in the first quadrant, it'll be positive. In the fourth quadrant, it's negative. Oh, no, it's not. It's still positive. X is positive in the fourth quadrant. We're still just looking at being pi over 6 away from the x-axis. In the second quadrant, we're going to have negative 1/2, positive square root of 3 over 2. And in the third quadrant, we'll have negative 1/2, negative square root of 3 over 2. These values, if we go around, we start with pi over 6, then 4 pi over 6, no. 5 pi over 6, 7 pi over 6, and 11 pi over 6. So pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6 all have the same coordinates. Square root of 3 over 2, comma 1/2. And all you have to do if you go in a different quadrant is change the sign. Well, we're almost done because we just got the relationship we were talking about before. Pi over 3 is double pi over 6. And we now know that if x is 1/2, then y has to be square root of 3 over 2. These coordinates always go together. So let's look at this page here. So pi over 3 will be 1/2 square root of 3 over 2. 2 pi over 3 will be negative 1/2 positive square root of 3 over 2. 4 pi over 2, I don't know why I paused. 4 pi, 5 pi over 2, thank you, is going to be over 3. Good grief, no wonder I'm really messed up. 4 pi over 3 is going to have coordinates negative 1/2, negative square root of 3 over 2, and 5 pi over 3 will have coordinates positive 1/2, because x is positive in the fourth quadrant, and then negative square root of 3 over 2, because y is negative in the fourth quadrant. So the key is, let me zoom out. Yeah.
I can do this about to dive out.
Oh, you can use that one. Are you, is yours charged?
I have a charge device, so I have an outlet.
Yeah, is yours charged enough?
Yeah.
Okay. So you can use this outlet.
Yes, sir.
Okay. And actually, y'all can both, I can find another way to plug this in. Or just live with it. Okay. So if you need yours still plugged in, Alex, that's fine.
Oh, it should be,
Well, let's plug it back in.
okay.
Guys, that side is sit over here.
That's fine. You can sit anywhere you want.
The laptop is better, like 2 minutes.
Yeah, that's another reason why I want to have everybody in class. So we can forget about computers and just use chalk and paper. Okay, so the unit circle has points that are special along the circumference and angles that are special inside. This is something I want you to know, but not memorize. What I want you to do is learn the first quadrant. 30, let's look at 30 degrees or pi over 6. All I have to do is drop a vertical down to the x-axis and a horizontal over to the y-axis. Does one of them look close to 1/2? That means that y must be 1/2, and that means that x must be square root of 3 over 2, because those go together. And that means that at 60 degrees, here if I drop a vertical, the x value is definitely the one that is smaller. It's the one that is 1/2. So x is 1/2, y is square root of 3 over 2. So you don't have to memorize which is which, but just remember, if you drop a horizontal and a vertical down, you can see that one of them is definitely closer to 1/2 than the other. And then 45 degrees or pi over 4, that's the one where they match. Square root of 2 over 2, square root of 2 over 2. Then the points repeat in every quadrant. We're just changing the signs. So in the second quadrant, x becomes negative, but the numbers are the same. In the third quadrant, both numbers are negative. And in the fourth quadrant, x is positive and y is negative. Okay, trig. We're going to start trig now, and we're going to do trig almost the whole semester. They call it pre-calculus because there's a little bit we do that isn't trig, but most of it is. So the definition of the sine is the y-coordinate of the point on the unit circle. So pick a point on the unit circle. The x-coordinate is going to be the cosine. Let's call this theta. X will be the cosine of theta, y will be the sine of theta. That's exactly how cosine and sine are defined. They are just points on the unit circle. This is the definition. This is how we came up with what they are. Everything else is in terms of sine and cosine. There are two quotient functions. Tangent is sine divided by cosine. Cotangent of theta is cosine divided by sine. Secant of theta is 1 over cosine of theta. And cosecant of theta is 1 over the sine of theta. That means that tangent and secant both have cosine in the denominator. So if cosine is 0, the tangent and the secant won't be defined. And if the sine is 0, the cotangent and the cosecant won't be defined. Okay, let's do a fun problem. Let's see, this point, which quadrant is this point in? The point negative square root of 5 over 3 comma 2/3. Good. And that's all we really need. So we've got the point negative square root of 5 over 3 comma 2/3. It's on the unit. Gee whiz, sorry. Turn off. I thought I turned everything off. Sorry. Un momento. Oh. Sorry, Amanda. Okay, all right. Well, remember that we define cosine to be the x and sine to be the y. So that means that the cosine, we're going to call that theta. The cosine of theta is negative square root of 5 over 3, and the sine of theta is 2 over 3. Tangent is sine of theta divided by cosine of theta. So we've got negative square root of 5 over 3 divided by 2 over 3. Anytime you have a complex fraction, a fraction inside of a fraction, the easiest way to simplify it is to multiply numerator and denominator by the inside denominator. So I'm going to multiply numerator and denominator by 3. So 3 divided by 3, they cancel. 3 divided by 3, they cancel. And now we have negative square root of 5 over 2. That'll be the tangent. The cotangent, do you see that cotangent and tangent are also related to one another? The cotangent can also be written as 1 over the tangent. So let's find the cotangent using the tangent we just found. The cotangent of theta will be the reciprocal of the tangent. What is the reciprocal of negative square root of 5 over 2? Good. And because Connect Math is Connect Math, you can't leave a square root in the denominator, so we have to rationalize. What can you multiply by the square root of 5 to get a whole number? Good. Whatever you do in the denominator, you have to do in the numerator. So we get negative 2 square root of 5 divided by 5 for the cotangent. So we've got 4 of them. Now we just have to finish. The secant is the reciprocal of the cosine. Secant is the reciprocal of cosine. And the cosine is negative square root of 5 over 3. So secant of theta is the reciprocal of cosine. Cosine is square root of 5 over 3, so secant will be negative 3 over the square root of 5. And how can we rationalize that?
Square root of 5 over square root of 5.
Awesome. So we get negative 3 square root of 5 over 5. And we just have the cosecant left. Cosecant is the reciprocal of the sine. The sine was 2 over 3. So what will the cosecant be? Good. Excellent. So once you find cosine and sine, you just have to simplify the rest. Tangent is sine over cosine. Yes.
Do you care about like having improper fraction or like mixed numbers? Like, for example, with like 3 over 2, like would you want?
Oh, no, I want it 3 over 2. Yeah, mixed numerals are not part of math going forward.
Awesome.
Yes, we call this an improper fraction, but let me tell you what, this guy votes, he participates in his community, he's a valued person. So Yeah, I think he's proper. All right. Because the values in the first quadrant are repeated everywhere else in the unit circle, you guys online, can y'all hear me? My mic is doing something weird. Can
I
you
can hear
go in the chat if you can hear me? Thank you, Brianna. Thank you, Carry On. Okay, thank you, Amanda. Good. All right. So this table, I want you to put somewhere in your notes. You don't have to memorize it, but it sure is handy. The sign of 0, remember 0 degrees or 0 radians is along the positive x-axis, and the point is 1, 0. That means the sine will be 0 and the cosine will be 1. The sine is 0, the cosine is 1. And then if we keep going around the unit circle, the first point we get to is 30 degrees or pi over 6. There the cosine, which comes first, is square root of 3 over 2. The sine is 1/2. And at pi over 3 or 60 degrees, they reverse. At 45 degrees or pi over 4, they're both square root of 2 over 2. And at 90 degrees, we're up at this point, 0, 1. So now the sine is 1 and the cosine is 0. Since the cosecant is the reciprocal of sine, and sine is 0, the cosecant of 0 is undefined. The reciprocal of 1/2 is 2. The reciprocal of square root of 2 over 2 is square root of 2. The reciprocal of square root of 3 over 2 is 2 square root of 3 over 3. And the reciprocal of 1 is 1. Likewise, secant is the reciprocal of cosine. The reciprocal of 1 is 1. The reciprocal of square root of 3 over 2 is 2 square root of 3 over 3. The reciprocal of square root of 2 over 2 is square root of 2. The reciprocal of 1/2 is 2. And now cosine is 0 at pi over 2. So that is where secant is undefined. The tangent is sine over cosine. So it's fine if the sine is 0, but not fine if the cosine is 0. 0 divided by 1 is 0. Square root of 3 over 2, pardon me, 1/2 divided by square root of 3 over 2 is square root of 3 over 3. At 45 degrees or pi over 4, x and y are the same, so the tangent is 1. Square root of 3 over 2 divided by 1/2 is square root of 3, and of course we're undefined when cosine is 0. Cotangent is just the reciprocal of tangent. The reciprocal of 0 is undefined. The reciprocal of square root of 3 over 3 is square root of 3. The reciprocal of 1 is 1. The reciprocal of 3 is square root of 3 over 3. And this is the only one that's a little bit weird. The reciprocal of undefined is 0, because our particular undefined was 1 divided by 0, and we're flipping it. So this is 0 divided by 1, which is 0. So this table will give you all the values for all of the trig functions for the whole unit circle.
We're gonna be able to use this one, please.
Absolutely. Like I said, I want you to have organized notes and then be able to find this information so that you get really good at that. And when you're in calculus, you go, they're saying this and this, and you go, oh, I know where that is. And you can use it. Okay. Theta is 7 pi over 3. The key is, first, where is 7 pi over 3? We know that 2 pi is all the way around. But I'm looking at something divided by 3. So I'm going to get a common denominator. So 6 pi over 3 is 1 revolution. What is 7 pi over 3 coterminal with? How do you find the coterminal angle? We're going to add or subtract.
Uh,
2 pi? Yes, very good. So this time we're going to subtract, and 2 pi for us is going to be 6 pi over 3, and we get just pi over 3. So the 6 trig functions,
Why are we subtracting 2 pi?
because 7 pi over 3 is larger than 2 pi. And I want to see what angle is related to or coterminal with this theta that's between 0 and 2 pi. So anytime it's larger than 2 pi, we'll subtract. And anytime it's smaller than 2 pi, we're going to add. So in this next example, theta is negative 3 pi over 4. Well, to see where that angle actually is, I need to add 2 pi. So I've got negative 3 pi over 4 plus 2 pi over 1. And what is the common denominator? Yeah. Oh, because I'm going to combine it with a fraction. That's not silly. So I'm writing 2 pi, instead of 2 pi, I'm writing 2 pi over 1 because I know I'm going to have to add a fraction. And so I'm just writing it so it looks like a fraction. That's a good question. And what is the common denominator? Good. So we've got negative 3 pi over 4 plus 8 pi over 4. And what is that? 5?
Oh, sorry, I was just looking at the data.
Oh, yeah. Okay. So 5 pi over 4. That means since the denominator is 4, that means that both x and y are the same. They're both going to be square root of 2 over 2. But one of them or both might be negative. So 5 pi over 4, what quadrant is that in? Is it the third or the, yes, absolutely right. So in the third quadrant, x and y are both good. So now we can use this chart to see all of the values. Cosecant, since sine and cosine are both negative, the only thing that changes is that all of the values, the cosecant and secant will be negative. The tangent and cotangent are going to be positive because we're dividing a negative by a negative. So the whole list, the cosine of this theta is negative square root of 2 over 2. The sine of theta is negative square root of 2 over 2. The tangent of theta, if the numbers are exactly the same, the tangent is 1 because we're taking sine theta and dividing by cosine theta. The cotangent, if you already have tangent, cotangent is easiest just to find the reciprocal of tangent. What is the reciprocal of 1? Good. The secant will be the reciprocal of the cosine. The cosine is negative square root of 2 over 2. And this is why I don't like rationalizing. Square root of 2 over 2 is the same as 1 over square root of 2. And it's easier to find the reciprocal of that number than it is square root of 2 over 2. What is the reciprocal of 1 over square root of 2? Good. And the cosecant will also be negative square root of 2. So the key is figuring out what the angle actually is between 0 and 2 pi, and then figuring out what quadrant it's in. We didn't finish this problem. Good grief, Nell. Oh, yes, we did. Pi over 3. So we had all those values. What if we had the angle what if we had been given 8 pi over 3 and we want to find all the trig functions? How do we find the coterminal angle between 0 and 2 pi? Good. So we have 8 pi over 3 minus 6 pi over 3, which is excellent. 2 pi over 3 is in which quadrant? Second. Second. Since we've got a denominator of 3, I know that the values are going to be the same as pi over 3, only some of them will be negative. In the second quadrant, what's negative, x or y? Good. So that means the cosine is going to be 1/2. The sine is going to be square root of 3 over 2. Which of these is going to be negative? Good. And the reason why I want you to have this chart is that sometimes dividing these things is frustrating. If you divide square root of 3 over 2 by 1/2, you get square root of 3. If you divide 1/2 by square root of 3 over 2, you get square root of 3 over 3. So the tangent will be square root of 3. The cotangent will be square root of 3 over 3. Are they positive or negative? Negative. Good. And why? Good. Yeah. Anytime the signs are different, tangent and cotangent will be negative. The secant is the reciprocal of cosine. So it's just going to be -2. The cosecant is the reciprocal of sine. And I lost it. There we go. And that's going to be 2 over the square root of 3. What do we have to multiply numerator and denominator by? Good. So we get 2 times the square root of 3 over 3. What if you have a point on an axis? So these next questions, we're looking at whole values of pi or half values of pi. If it's a whole value of pi, you need to figure out, is it even or odd? Is 4 even or odd? Even. That means that it's going to end up here. And it's negative 4 pi, so it's twice around in the negative direction, but still it's going to end up at this point, 1, 0. So what is the sine of theta? Good. And the cosine? The tangent? It's 0 divided by 1. 0. Good. The cotangent is undefined. Good. The secant is the reciprocal of cosine. What is the reciprocal of 1? And the cosecant is the reciprocal of sine. What is the reciprocal of 0? Good. If you have a half angle, half pi, in lowest terms, then you need to figure out, is this at the top or bottom of the unit circle? If we look at between 0 and 2 pi, we've got pi over 2 at the top, then pi, then 3 pi over 2, then 2 pi. So I need to figure out, is 11 pi over 2 at the top or the bottom? It's at the bottom. How did you know? Good. So (11 pi over 2) is coterminal with 3 pi over 2. So I know the coordinates of that point. X is 0, y is -1. So what is the cosine of that angle? Cosine goes with x. And what is that? Good. What is the sine of that angle? And then everything else goes from there. Let's do the tangent. -1 over 0. Good. The cotangent is 0 over -1. Good. The secant is the reciprocal of 0. And if,
Yeah,
that's what you meant.
yeah.
And the cosecant is the reciprocal of the sine. Good. So when you look at points that are on the unit circle, on an axis, all you have to figure out is, am I at the positive edge or the negative edge? Am I at the top or the bottom? Okay, let's do something that's actually really, really fun. They tell us that the sine of theta is the square root of 33 over 7, and that we're in quadrant 2. square root of 33 over 7. How can I figure out what x is?
Are we to use that formula, the x squared plus y squared equals 1?
Yes, absolutely perfect. So we've got square root of 33 over 7 squared. What is square root of 33 over 7 squared? Over. And if I subtract 33 over 49 from both sides, I'm going to write 1 as 49 over 49. Can I do that? And subtract 33 over 49. And what do we get?
Negative 16 over 49.
Perfect. And that's really nice because we can take the square root of that number and not get an irrational number with no square roots. And what do we have to put in if we're taking the square root of both sides of an equation? Awesome. So we get x is equal to positive or negative 4 over 7. My bad, I wasn't paying attention. I apologize. We're in quadrant 2. Is x positive or negative in quadrant 2? Good. So that means the cosine of theta will be negative 4 over 7. We know the sine is the square root of 33 over 7. So let's find the rest. Let's find.
I have a question. Why is it 4 over 7? I don't think 16 over 49 drops down like that.
Square root.
It's the square root of 16 over the square root of 49.
Good. That was a good question because that would be really frustrating not to figure that out. Yes, very good question. To find the tangent, we want to divide the sine by the cosine. And I notice that both fractions have a denominator of 7. That means I can multiply top and bottom by 7 and get rid of those denominators. So that the tangent is just negative square root of 33 over 4. That's not a beautiful 33, sorry. Tangent theta. What about the cotangent of theta? Yeah. And because connected math is going to be part of our lives for a while, what do we have to do? And we get negative 4 times the square root of 33 divided by 33. The secant is the reciprocal of cosine. The cosine was negative 4 over 7. So what is the secant? Excellent. The cosecant is the reciprocal of sine. The sine was square root of 33 over 7. So what will the cosecant be? Excellent. And we multiply numerator and denominator by square root of 33, and we get 7 times the square root of 33 divided by 33. This notation is notation I want to be able to use, so I want you to know what this means. T is in quadrant 1. That epsilon symbol means in. So if the cosine of t is 5/8 and t is in quadrant 1, I know that cosine is the x coordinate on the unit circle. So the x coordinate is 5/8. How can I find the y coordinate?
X squared plus y squared.
Excellent, excellent. So we have 5/8 squared plus y squared is 1. What is 5/8 squared? Excellent. And I'm going to subtract 25/64 from both sides. So y squared, I'm going to write 1 as 64/64. And we're subtracting 25/64. What is 64 minus 25? Okay, yeah. So we get 39/64. And I think there are no common factors. And how can we find y? All right. And even though we know y is in the first quadrant, we're pretending we don't know that yet. So we still have to put plus or minus.
So would it be the square root of 39/8?
Yes, very good. Very good. And let's just go through the rest. We know that the sine of t is the square root of 39/8. We've got the cosine. Let's find the tangent. What is tangent? So we have square root of 39/8 divided by 5/8. Both of these denominators are 8. So I'm going to multiply by 8/8 and get rid of those denominators. And we're left with the square root of 39/5. How can we find the cotangent? Do you want to use cosine over sine or 1/tangent? Okay. So what is the reciprocal of the tangent? Awesome. The secant of t is the reciprocal of cosine. The cosine was 5/8, so what is the secant?
Eight over 5.
Good. And the cosecant is the reciprocal of sine. The sine is the square root of 39/8. So what is the cosecant? Excellent. So we're going to be doing this same kind of thing all semester. We're going to be starting with some value and finding the rest of the values from that one value, usually using this Pythagorean relationship. Okay, I need to talk a little bit about algebra review, but I tried to make the notes complete so that all the words that we use in class are defined. The domain of a function is all the possible x values you can plug in. The range of a function is all the resulting outputs, or domain is the x, range is the y. Periodic means I can add something to a function and it doesn't change it at all. P is the smallest, if P is the smallest value that causes this to happen, P is called the period. A function is called even if when you plug in a negative, it doesn't change the function at all. We say even functions are symmetric with respect to the y-axis. One even function is x squared, and you can see it is symmetric with respect to the y-axis. And I can also see that this works because I can plug in -2, f of -2. Well, that's -2 squared, and what is -2 squared? Which is exactly the same as +2 squared. So that's why x squared is even. Odd means if we plug in a negative, we get a negative. Odd functions are symmetric with respect to the origin, which means I have to reflect twice. I have to reflect the first quadrant into the second and then into the third. Do you see that? This happens to be a graph of the cube root of x. But do you see if you take this part in the first quadrant, flip it into the second, and then flip it into the third, that they will match? That's what symmetry with respect to the origin means. We're going to investigate these properties more, but right now I want to give them to you. Since sine and cosine repeat every time you go around the unit circle, the period of the sine is 2 pi. The period of the cosine is also 2 pi. Since every point on the unit circle has a point, has an x and a y, the domain for the sine is all reals, and the domain for the cosine is all reals. Sine is odd because if you plug in a negative, you get a negative out. Cosine is even because if you plug in a negative, you get a positive value. And everything else is based upon sine and cosine, except the tangent and cotangent. So I don't know why I did this backward. Cosecant, every time, since cosecant is the reciprocal of sine, every time sine is 0, the cosecant is not defined. Well, sine is 0 every single multiple of pi. So the cosecant isn't defined every single multiple of pi. This notation is all theta, and this line here is the words such that, and then the condition, theta isn't equal to n times pi for any integer n. Who can tell me what integers are?
Whole
Give me,
numbers.
pardon?
Whole numbers?
Yeah, whole numbers and negative whole numbers and 0. So 1, 5, 11, -4. Yes, exactly. The secant is undefined anytime the cosine is 0. Well, cosine is 0 at the top or the bottom of the unit circle. That means odd multiples of pi over 2. 2n plus 1 is a way to write every single odd number. You start with an even, 2n, and add 1 to it to get an odd number. So that means that secant and tangent are going to go together because they both have cosine in the denominator. Cosecant and cotangent are going to go together because they both have sine in the denominator.
Could you, for that equation, could you just write n plus 1 times pi? Is
In,
that the same thing as 2n plus 4 times 1?
okay. So we can write, we've got 2n plus 1 pi over 2. So I can multiply the pi over 2 through. That would give me 2n pi over 2 plus pi over 2. And yeah, we just get n pi plus pi over 2. Very good. And that even makes it plainer. We start with an even multiple of pi, and we add pi over 2 to it. And we'll always end up on the y-axis. Since sine is odd, cosecant is odd. Since cosine is even, secant is even. Since sine and cosine are opposite, and an odd divided by an even is odd, tangent and cotangent are both odd. The period of sine is 2 pi. That means the period of cosecant is 2 pi. The period of cosine is 2 pi. That means the period of secant is also 2 pi. But tangent and cotangent are a little different. They repeat every pi units. So the period for tangent is pi, the period for cotangent is pi. All of these things will become clearer in the next few days, but these are facts that you need to have at your command right now. So if we have sine and we add 2 pi or 4 pi or 6 pi to it, that's the same as the sign of that number. You can just take the 4 pi or 2 pi out. If you have cosecant of a negative number, then you can just bring the negative out, and that's the same as the cosecant of the positive. So that's what we're going to do. We're going to take these properties and simplify. So first, what if we want to find the sine of 49 pi over 12, and we know the sine of pi over 12? How can I relate those? 49 pi over 12 and pi over 12.
That's 49, I guess, rotations. And that's an odd number. And on the x-axis.
Well, we've got a denominator of 12. So we have to get a common denominator, really, to see what's happening. So we've got 49 pi over 12 minus 24 pi over 12. What does that leave? Good. And that means we're still larger than 2 pi. So I'm going to take 29 pi over 12 and subtract 2 pi again. And what do we get? Where is 5 pi over 12? Which quadrant? In other words, is 5 pi over 12 greater than pi over 2 or is 5 pi over 12 less than pi over 2? Oh, thank you. Thank you so much.
Oh, yeah, they're right.
Isn't 25 pi over, isn't it 25 pi over? Yes, you're absolutely right, Brianna. Thank you. So this is 25 pi over 12. Good. I was wondering about it, but 25 pi over 12. And we subtract 24 pi again, and we get pi over 12. I was not sure why I asked something that was hard. So that means that we could write 49 pi over 12 as pi over 12 plus 4 pi, because that's what we did. We started with 49 pi over 12 and subtracted 2 pi, and then subtracted 2 pi again. And that means we're trying to find sine. We've got the sine of pi over 12 plus 4 pi. What does the periodic nature of sine say that we can remove? Good. So that's equal to the sine of pi over 12, and we know the sine of pi over 12. Square root of 6 minus square root of 2, all divided by 4. Well, let's do more. Here we've got 4 times the tangent of negative 3t minus 5 times the tangent of 3t plus pi. So let's look at tangent. Is tangent even or odd? Odd. That means if I've got a negative inside, what can I do with that negative? Yeah, it goes out front. So 4 times the tangent of negative 3t is negative 4 times the tangent of positive 3t. And then we've got 5 times the tangent of 3t plus pi. What is the period of tangent? Pi. So how can I rewrite 5 tangent 3t plus pi? What can we just take out? Good.
So would it be positive 5?
No, the negative stays because we haven't changed anything about the sign, SIGN, but we can take that pi out. And now we have like terms. We have tangent 3t and tangent 3t, and we can combine them. And what do we get? Good. And that was the goal, to try to combine these into one term. Okay, here we go again. Is cosine even or odd? It's even. That means if I've got a negative inside, what do I do? It
Or
just,
actually, no, just
good. Okay. What is the period of cosine? 2 pi. So what can I do with this 2 pi? Good. So the first term becomes negative 3 times the cosine of 5t. Good. We've got negative 3 plus 1, so negative 2 cosine of 5t. So we're looking at even and odd and period to simplify and make them look the same. The Pythagorean theorem, a squared plus b squared is c squared if you've got a right triangle, and c is the hypotenuse. Well, if we put if we put our right triangle in the unit circle, so that the first coordinate is cosine and the second coordinate is sine, we know that the hypotenuse of the unit circle is 1. If x is cosine theta, what is this base? It's just the distance in the x direction. What is the distance in the y direction? Good. So now we've got a triangle with cosine theta, sine theta, and 1, which is the most, besides the Pythagorean theorem, the most famous Pythagorean theorem is sine squared theta plus cosine squared theta is 1. If you do memorize anything, I would really like it if you memorize that. The way to get the related Pythagorean identities is to take sine squared theta plus cosine squared theta equals 1 and first divide everything by cosine squared theta. So let's divide everything by cosine squared theta. And now I'm going to rewrite. I've got sine squared theta divided by cosine squared theta. I'm going to write that as sine theta divided by cosine theta all squared. And I'm adding, what is cosine squared theta divided by cosine squared theta? Yes, absolutely. And I'm going to write 1 over cosine squared theta as 1 over cosine theta squared. And yes, how can I rewrite this now? The secant goes with cosine and the cosecant goes with sine. They always mix it up. So it'll be the secant squared theta. It's kind of backward. If we start with sine squared theta plus cosine squared theta equals 1 and divide everything by sine squared theta, excellent. So the other two identities are tangent squared theta plus 1 is secant squared theta, and 1 plus cotangent squared theta is cosecant theta. It helps to solve one of these, at least one, for the other. So if we start with sine squared theta plus cosine squared theta equals 1, how can I solve this for sine? Okay, so cosine squared theta is 1 minus sine squared theta. And what do we have to do when we take the square root? Oh, okay, sorry, my bad. I'm sorry. Okay, so for sine, we would get plus or minus the square root of 1 minus cosine squared. And what is the square root of sine squared? And then similarly, cosine theta is plus or minus 1 minus sine squared theta. I want y'all to solve tangent squared theta plus 1 equals secant squared theta Solve that for the tangent. So solve for tan theta. Almost. Get tangent square theta by itself first. So what do we have to do to get tangent square theta by itself? All right. So tangent square theta is secant square theta minus 1. And we get tangent square, the tangent of theta is plus or minus secant square theta minus 1. Is that what you said?
Yes.
Okay. I said it out loud in my head and realized that that's exactly what you said. I apologize. I'm very fallible. I make mistakes. Fallible. Thank you. What about, let's solve the second equation for cotangent of theta. I'm sorry, Alex, what'd you say?
That's what I can answer.
Oh, okay. So somebody help me out here. We're solving 1 plus cotangent square theta equals cosecant square theta for cotangent theta. So what do we do first? Somebody help me. Alex has been helping. Kennedy has been helping.
Subtract 1.
Excellent. So we get cotangent square theta is equal to cosecant square theta minus 1. And now what?
Square root everything.
Excellent. And what do we have to do when we take the square root of both sides?
And add or subtract.
Yes. Plus or minus. And now what?
And you have cosine theta, or cotangent theta, I'm sorry, equals plus or minus the square root of cosecant squared theta minus.
Like this? Excellent. So let's do something. Let's find, we're going to ignore where theta is at first. Let's find cosine theta if we know that the sine of theta is -5/12. So what am I going to use to find cosine theta?
still going to do the x squared plus y squared equation?
Yeah, well, we're gonna do it in the form of sine square theta plus cosine square theta equals 1, where the sine of theta is negative 5 pi over 12, negative 5 over 12. Now what? Pardon? Well, we're gonna move the, after we square negative 5 pi over 12, we'll move that over. Because cosine's already positive. So usually the thing you're looking for, if it's positive, you just leave it.
Sure.
So what is negative 5 over 12 squared? Excellent. And we're going to subtract 25 over 144 from both sides. We'll get cosine square theta is equal to, I'm going to write 1 as 144 over 144. And we're subtracting 25 over 144. And what do we get? Oh, yes. And so the cosine of theta is going to be
Oh, this part.
good. And now finally, we can see whether we're going to use a positive or negative of the plus or minus sign. We're going to look to see which quadrant starts at 3 pi over 2 and goes to 2 pi. Good. So we could say theta is in quadrant 4. And in quadrant 4, cosine is x, remember? So in quadrant 4, is x positive or negative? Positive, good. So our answer is the cosine of theta is positive 119 over 12. I want y'all to do this one for me, but tell me what to do. So what do I need to write down in order to find secant t if I know tangent t?
Secant is the reciprocal of tangent.
Cotangent is the reciprocal of tangent. The way that secant and tangent are related is the Pythagorean identity. Tangent square theta plus 1 is secant square theta. So let's write that down. Tangent square theta plus 1 is secant square theta. So how do I find secant theta? Or secant t?
Plug in the numbers. for
Okay.
tangent.
Excellent. All right. And negative 12 over 5 squared is all right, good. And I'm going to write 1 as 25 over 25 so that I have a common denominator. Yep. So the secant square theta, or t, no, t. There you go. So the secant squared of the angle is 169 over 25. What is the secant?
The square root. So, 169.
Good. And the square root of 169 is
The square root of 169.
13.
13.
Good. And the square root of 25?
5.
Good. So secant t is either positive or negative 13 over 5. Now we need to see where is t. So which quadrant starts at pi over 2 and goes to pi? Good. So t is in quadrant 2. Secant is connected to which sine or cosine? Good. Secant is related to cosine. Is cosine positive or negative in quadrant 2?
Cosine is negative.
Good, because it goes with x. So we get that the secant of our exact angle
Wait, it's negative.
is negative 13 over 5. Yes, very good. Do you see that we're solving things that look the same over and over again? Something squared plus something else squared equals 1. We're going to do that all semester. Okay,
So is that why you want us to know these charts? We're literally just going back to all these charts that you have.
partly, yes. The reason why is that those values, those are the nice values. They'll come up so often that the more you. What did I do? I got you, didn't I? Okay, sorry. So the better that you know those values, that can be like on the side. You don't have to remember them anymore.
Okay,
And you can concentrate on something that's different.
okay, yeah, like some of them, I was wondering where you got it, then I looked at all the other charts, like, oh, I see you got it.
Yeah. Okay, this is another thing I want you to follow, but you're not responsible for reproducing it. So what we want to do, a lot of people learn trig, sine, cosine, and everything based on a right triangle. Well, we defined it based on a unit circle. We want to connect those. We want to connect the unit circle definition with the right triangle definition. So we've got this point P of xy, where x is the cosine of t and y is the sine of t. As long as this, actually, we don't know that because we don't know the length of this radius. If the radius is 1, then we know that. So we've got several things going on here. We've got the unit circle. We've got a point on the unit circle. We've got the radius of the unit circle. We've got this angle T. If you start at point A and go vertically down to the x-axis, you get point B. And then we've got a point P of x comma y. If you start at point P and go vertically down, you get to point Q. So we have 2 triangles we're going to look at. O is the origin, OAB and OPQ. And I think they intended for, I thought I liked this drawing better than I like it. I think R is intended to be this entire distance from the origin to the point P. And the distance from the origin to A is 1. That's on the unit circle. So we've got, so the point A is cosine T comma sine T because it's on the unit circle. And we know if the angle is T, then that point is going to be cosine T comma sine T. So let's see. We've got similar triangles. We know that OAB is similar to OPQ. What that means is two of their angles are the same, which implies all three of the angles are the same. They both have angle T at the lower point, and they both have right angles at another point. That means that we can write proportions for the sides. That means things like P to Q divided by O to Q has to be the same as, let's look at the vertical distance. So AB divided by OB. So we can figure out how to talk about this point P by looking at these different relationships.
It seems to me that both of them are 30, 60, 90.
Well, they look like 30, 60, 90, but it doesn't matter what the angle is.
Oh.
This will still work. So we do have that AB over OA is equal to PQ over OP. And the thing that's nice is we know some of these values. OA, well, that's the unit circle radius. So that's 1. AB, that's the distance from A, the vertical distance from A to the x-axis. And the vertical distance will be the sine. It'll be the y value. So AB is going to be the sine of T. PQ is going to be, it's a vertical distance, so it's going to be y. And OP is R. So we get that the sine of T is equal to y over R. Similarly, OB over OA is equal to OP over OQ. OB, that's the x distance to the point A. That means we're looking at the cosine. OA, that's going to be 1. OP, that's R. And this is flipped. OQ over OP. OP is R. And yes, OQ, the distance from O to Q along the x-axis is going to be x, because the coordinates of P are x comma y. And that's how we get that the cosine of T is x over R. If sine is y over r and cosine is x over r, we can write all of the trig identities using x, y, and r, where r is the radius, y is the y coordinate, x is the x coordinate. Cosecant will be the reciprocal of sine. Secant will be the reciprocal of cosine. Tangent is sine over cosine. The r's divide out and we just have y over x. Cotangent is the reciprocal of tangent. And all of these are connected with the words opposite is going to go with y. Hypotenuse will go with r. Adjacent will go with x. Hypotenuse, opposite, adjacent, hypotenuse, opposite, hypotenuse, adjacent. Where those words if theta is here, the hypotenuse is always the side opposite the right angle. The adjacent is the side closest to theta. The opposite is the side farthest away. Some people remember these formulas by SOHCAHTOA. Yeah, sine is opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. So let's draw a triangle. There's a 7 centimeter side that is opposite, a 4 centimeter side that is adjacent, we need to find the hypotenuse, and then we can write the 6 trigonometric functions. Oh, and this is supposed to be angle A, and then the angle B. Okay, so how can we find C if we know the base and the height?
Use tangent.
Oh,
Never mind.
yeah, we could use tangent, but you're ahead of us. First, we just need to find the hypotenuse.
49 plus 16 equals c squared.
Good. And what is 49 plus 16?
$65.
Excellent. So one thing about triangles, actual triangles, is that all of the lengths are positive. There's no triangle with a negative length. So when we take the square root of both sides here to find C, we just disregard, we don't even need to put the negative in the plus or minus sign, we don't need to put it because we're looking at actual lengths. Now that we've got all 3 sides, tell me what the sine of A is. Remember, based on triangles, sine is opposite over hypotenuse.
Seven over the square root of 65.
Good. We're going to rationalize later. We know the sine, so does that help us find the cosecant of A? What is the reciprocal of 7 over 65, square root of 65? Excellent. What is the cosine of A? Cosine is adjacent. Yeah. And that means that the secant of A will be
Square root of 65.
excellent. The tangent of A, tangent is opposite over adjacent, so what will tangent A be?
7/4.
Excellent. And what is the cotangent of A?
4/7. 4/7.
Or
Excellent. Okay, now I want you to do something fun. We did opposite, adjacent, and hypotenuse with respect to angle A. Let's not redraw the triangle, but let's think about angle B. What side is adjacent to angle B? Which side? The sides. It's always going to be a side.
Oh,
It's the opposite.
Which side is adjacent?
see,
The hypotenuse is not ever a side.
the 7 centimeter side.
Good. So for B, from the point of view of angle B, the 7 centimeter side is adjacent and the 4 centimeter side is opposite. That means that we can do all of these same things. It means that cosine and sine will just be opposite. Cosine will be what sine was, sine will be what cosine was. Let's see. Sine of B, sine is opposite over hypotenuse. Opposite over hypotenuse. So 4 over square root of 65. And do you see that's exactly what we had for the cosine of A? And the cosine of B, that's adjacent over hypotenuse, 7 over the square root of 65. That's the same as the sine of A. That always works. If you have two angles in a right triangle, they flip sines and cosines. The sine of A equals the cosine of B. The sine of A, and the cosine of A equals the sine of B. So the sine of A equals the cosine of B, and the cosine of A equals the sine of B. And everything else comes from those. So this is the key thing I want you to remember. And that's why cosine has a co, because it's related to the sine. And they're called co-functions. So here's a triangle with everything filled in. It's a 12, 16, 20 triangle. And from the perspective of, or from the point of view of angle theta, what side is opposite? Which one? Good. And the adjacent, good grief. Oh. That was on purpose. This is a break. I knew I would forget if I didn't set a timer. So let's take a break. Yeah.
Oh, it's like positive.
At,
Yeah.
let's just keep going. You're kidding. Okay, so I really messed up the break.
10-minute break.
Okay, I apologize, guys. I will,
That was the question.
okay, I intended to have a break and, next class, well, let's talk about logistics real fast. Everyone is coming to class on Wednesday. Let's all come. And then we don't have to Zoom and I'll still have notes that I'll send out, but, I'll have notes on the board and chalkboard and all that stuff. What was the other thing? Logistics.
The notes that you're gonna have for Wednesday, like, set those out for the class.
Yeah, I'll have them online tomorrow, by tomorrow. Yes,
Didn't you say they weren't gonna be like as long people?
in future, right, yeah, the notes won't be as long. And some of the notes for next time are gonna be from the end of these notes,
Oh, cool.
because we gotta finish it. There was something else. Now I don't remember it, so I'll remember it later. But anyway, everyone come to class on Wednesday. We'll figure out the seating. And it'll be a lot nicer. If for some reason someone can't come, then I will Zoom and record it so that everybody has a chance. So let's finish this. We have time to finish this one problem. Since 12 is opposite, 16 will be adjacent, and the hypotenuse will be 20. This is relative to angle theta. What about relative? What would you call this angle up here? What is the value of it? Question mark is equal to,
90 minus 30,
yeah, why?
because all of the angles have to.
That's right. If you've got a 90-degree angle, and so you take that away from the 180, you're left with 90, and that means the other two angles have to add up to 90. So we're going to call the second angle 90 minus theta. With respect to that angle, what is opposite? And adjacent? And of course, the hypotenuse stays the hypotenuse. And do you see that by identifying the sides in this way, it's really easy to write down all the values. So let's just do a few of them. Sine of theta will be what?
Twelve or 20.
Good. And can we reduce that? Good. That means that the cosine of 90 minus theta must be also 3/5. They always go together. What is the cosine of theta? And can we reduce it? Good. That means that the sine of 90 minus theta is also going to be 4/5. The tangent is opposite over adjacent. What is the tangent of theta? It'll be just the sides. So opposite is going to be 12. What is adjacent? Yeah. And that reduces to Pardon? Yes, very good. That means that the cotangent of 90 minus theta is going to be 3/4. Let's do the cotangent of theta. The cotangent is adjacent over opposite. So what is the cotangent of theta? And that reduces to and that means that the tangent of 90 minus theta is going to be 4/3. The cosecant is the reciprocal of which one? Yeah, sine goes with cosecant. Cosine goes with secant. So we've got what is the reciprocal of 3/5? That means that the secant, they're co-functions. One has a co and the other doesn't. That means the cosecant, the secant of 90 minus theta is also going to be 5/3. The secant is going to be the reciprocal of which one? Yes. And that means the cosecant of 90 minus theta is also going to be 5/4. So everything is connected. That's what I'm hoping that you see from today's lecture. Please sign in to Connect Math. If you go to our Canvas site, there we go. The code and the link for Connect Math are here. So here's the Connect Math link, and here's our code, UCW4L-PFKGC. Please sign in to Connect Math and do as much of the first 2 assignments as you can. That way, when you come back on Wednesday, we can talk about any questions that you have over sections 4.1 and 4.2. And then we'll finish up. We're actually in section 4.3. So you should be able to do all of 4.1 and 4.2. We'll finish 4.3. And then this material, oh, and this is another thing. Every quiz has a practice quiz. So this week, that means you have to do the practice quiz to get ready for the quiz. Quizzes are like practice quizzes, almost identical, except that the options, if you go into Connect Math, it's really slow today. So if you go into Connect Math, la, 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 hit the dots. It's very slow, la, la, la. Okay, usually there are these buttons along the right-hand side. Solve it, guided solution, show example, link to textbook, ask my instructor, and print. Those are all available for every assignment except the exams and the quizzes. Or for exams and quizzes, you only get ask my instructor. So if you're in a quiz and something isn't working, click that, type it to me. What I get is a screenshot of what you're doing. And I can answer you right away. It comes right to my phone. And it will come back to whatever email is connected to your Connect Math. So I'm trying to make it pretty fair. Nothing is very long. But I do want you to practice. When you're doing the homework, try to use your notes, effectively. Try to get organized with your notes. And the better you are with that, the better calculus will be. Definitely. All right, any questions? Yes,
I got a logistics question.
excellent.
So if, like, let's say tomorrow somebody can't make it or whatever, and it's on Zoom, does that mean that all of us have to be on Zoom?
Yeah, if somebody can't come, that's a good question. If somebody can't come, and that means that they have to Zoom, there's not a way for me to record the board. So I couldn't even just record it and save it for them for later. And if I Zoom, then for one person, then everybody's stuck using the overhead. So try not to be sick.
I almost want to say just keep it how you have it already, but
Well, let's try to have regular class. Let's just make it a goal and see how it goes. If it really seems horrible, then we'll just do it like we started. I'm willing to be flexible, definitely. Because we're all going through a weird stage.
so they
Post-pandemic.
don't come during inclement weathers.
Yeah, and now if the weather is horrible,
Yeah, like I wasn't gonna come today, but I was like, let me just try the first day of school. So-
yeah, I'm glad you did. If the weather is bad, then what I'll probably do is Zoom from home. So if it's horrible, look, see, have I sent you an email? And, oh, that's another thing. Please check please check Canvas at least once a day. Because that's where I communicate with you. And yes, definitely, if the weather is bad, I'll Zoom from home.
I have another question. So our
All right.
exams are gonna be here in class.
The exams are in class, everything else is online. And that means the quizzes are online and you do them whenever. I thought about doing that with exams as well, but it's just, I like it better seeing people work. And you'll get better practice using your notes. Everything is open notes, but you have to be organized. And the more organized you are now, the easier calculus will be.
And the exams, we're gonna have like a sheet of paper, right? That's our
Yeah, they'll be
exams.
printed.
Okay, I was gonna say that because, we have less desk space using our computer.
Oh, yeah, no, yeah. No, they'll be printed. Let's see. So printed exams and the exam dates. The midterm is the first one that we care about. That's going to be on the 28th of June, which is 3 weeks from now. 1, 2, 3, that's right. Wow. And then the final is the last class date, the 28th of July, which is a Wednesday.
And we're taking those at home because those are on Connect Math, correct?
No, we're going to take them in here. The dates, I know, but
We might have everyone plug in a computer. 'cause-
I'm going to take the test that is online
Okay.
and generate a better one for
Oh,
paper.
That makes sense. I was like, we all need to plug in our computers now.
No,
Okay.
yeah. So that's another reason why I'd like everyone to be here. You don't have to worry about plugging in. Then it'll be more like the real world, normal world, whatever that is. Any questions at all before we sign off? Well, thank you all for coming. And have a wonderful day off tomorrow, and I will see you Wednesday. Everyone here.